So here I want to show you another examples of how to approach U substitution without actually substituting everything by U. So I'm writing out my example. Okay. So what I would do first is to rewrite the whole thing. Oops. Sorry about forgetting that sign. To rewrite the whole thing so that it gives you the better sense of the power of the U that you're actually trying to take an antiderivative of. See this part right here. It's really important that you don't write it wrong, because if you do so, then it's not gonna give you the correct answer. Okay. So the next step I would do is that to notice that in the part of the U here, sort of speaking, U here, if you're trying to take the derivative of this part, it should give you 2x, because the h is going to be 0. It's a constant. And then notice that this is not quite the derivative that's coming out of the inner part. So now we want to compensate for this. Now, by doing that, simply just to ask yourself a question: how am I going to, what number should I multiply it by to get 3x? Just do a simple math right here. So, right, this is what you should put in front of the whole thing. So this is step 1. And step 2, since you're taking the antiderivative of the whole thing, you should add a 1 to its power. So negative 1/2 plus 1 is going to give you positive 1/2. Now, this is something that you want to really be careful of, because oftentimes when I do these problems, like I would do it wrong, because I would add the numbers wrong, and then once you get the number wrong, then you really you would just do the whole thing wrong, because it really affects a lot. Now once you get 1/2, okay, so I'm gonna write it here. So 1/2 is the power of your antiderivative function. Now notice that when you try to take the antiderivative of the whole thing, you should multiply the whole function by 1/2, right? And then subtract 1 up top. But hold on a second. There's nothing indicates the 1/2, the existence of 1/2 here, right? 3x, right? And now you want to compensate for the 1/2. So again, ask yourself, how can you get 1/2 to fit in? So imagine there's a 1 times 1 right here, and something times 1/2 is going to give you 1, and that's easy. Everyone knows that. You don't need a calculator for that, right? It's just going to be 2. Okay. Now, 1/2. Sorry, it gets a little bit messy right here. I'm gonna erase some part of it so that you can see more clearly. 1/2. Okay. Oh, don't forget to write C here, because it's a constant. And so this is how you would actually think backwards instead of substituting everything with U. And the final step, the very last step, is that you want to verify your answer, like see if it matches the original function. So you would just take the derivative of your answer, right? So this is just gonna give you 3, right, plus C, and then you times this, times, and you subtract 1. C is just going to be 0 since it's a constant, then you take the derivative of the inner part, so it's going to be 2x times 3 halves times this, and then this is just going to be 3x. So 3x times the whole piece right here. And this is exactly the original function, so now you know you're doing the everything correctly. So this is how I would approach these type of problems without substituting everything by you. And this is